Thank you very much. Good morning, everyone, and welcome to this online workshop, which deals with the contribution of water efficiency and energy savings. This online workshop has been organized by the European Alliance to Save Energy in cooperation with the government of Malta, which I very much thank. And I do remember when we went to the formal council in Malta, and we also dealt with this very issue. So thank you very much for your support in dealing with this point. So the objective of this high-level workshop is to put the attention on this nexus that is really indispensable to deal properly with, on the one side, resource efficiency and water proper use, and energy, the transformation of our energy system in the framework of the Green Deal, and of this major endeavor that is to change our certainly energy system, but also economic one. We have a series of very interesting and very competent speakers because we have two objectives. One is to talk about this water efficiency and energy saving nexus in the framework of a legislative I would say storm, a concentration of a lot of legislation which is coming up, notably in the area of energy efficiency, but not only. We are talking about the EPBD, we're talking about the ED, but we are also talking about the industrial emission and the industrial emission directive, which in theory are not legislation for which you would think about water immediately. But we are absolutely convinced, and this is actually the first goal of this of our workshop, that not only there is a strict connection, but there is a need to regulate this nexus. It is not enough to say, yes, there is a connection between saving waters and dealing with the save energy, but we need to have some kind of regulation, otherwise this remains something which is too vague. And the second objective is to show that this is not only possible, but it is already happening, although not in the scale that we would like it to have it, and that is why we ask for a stronger legislation. And that is why we invited some of the members of the European Alliance to Save Energy to tell us about how they concretely can show that this nexus is beneficial. So without further ado, and thanking to you again to be here with me to talk about this very important point, I would like to give the floor to my co-host, Miriam Dalli, who is the Minister of Energy, Enterprise, Sustainable Development, which I think I came across in the European Parliament. Madam Minister, please, you have the floor.
Thanks a lot and good morning. And yes, Monica, we did cross paths already, and it's good to be here to also talk about this very important topic. Today, I'm representing the Maltese Ministry for Energy, Enterprise and Sustainable Development. And on behalf of my ministry, I'm really glad to welcome you to our joint workshop on the nexus between these two extremely important resources, energy and water, the effective management of which is key to achieve our sustainability ambitions. So with this in mind, I would like to share with you Malta's experience and achievements in applying the Nexus approach in the development of our water sector. So when we speak about Malta, we're speaking also about Malta's natural, climatic and geographical conditions, which limit the development of natural freshwater resources. And in turn, water availability has historically been a limiting factor for social and economic development. Available natural resources in Malta are not sufficient to meet the national demand for water. Thus, as a country, we require the production of alternative water supplies so that we can ensure security of supply. The higher energy requirements associated with water production invariably raise the importance of energy efficiency in water management, particularly since affordability of water has to be maintained. So if I go back in time, seawater desalinization, was first considered in the mid-60s with the commissioning of multi-stage flash distillation plants, and they were commissioned as a solution to the increasing water demand, which was resulting from a sharp increase in the population and also from increased economic activity. The technology proved to be vulnerable to energy demand and was discontinued following the increase in the cost of electricity after the 70s energy crisis. Now, the foundation of Malta's long-term water management framework were then laid in the early 80s with the decision to invest in reverse osmosis seawater desalinization, which back then was a relatively new technology. The increase in water production capacity ensured security of supply. However, this came at a cost, with the energy requirements for water supply in the early 1990s reaching nothing less than 20% of all the national energy demand. Now, at the time, the most energy consuming service in households was actually water supply. To address this, Malta launched then a leakage management campaign to control national water demand, where linking water demand management and water supply augmentation measures was key in ensuring long-term security of water supply. Stability then led to an increased focus on energy efficiency in the provision of water services, leading to the development and adoption of new technologies and practices to progressively increase energy efficiency in seawater desalination. The success of this approach lies in the fact that today, energy requirements for water services provision is down to 6% from the 20% I mentioned earlier of the national energy demand. And today, the most energy consuming service in households has become the refrigerator. Now, reducing energy requirements for seawater desalination increased the relative relevance of energy use within the whole water service cycle. And this has enabled the rethink of the National Water Management Framework, which led to the development of the net zero impact utility concept. Now, this is also supported by the EU Cohesion Fund, and this project that we are working on seeks to transform our water services provision into one which is focused on limiting its impact on the environment. And we're doing this primarily through two pillars. First, returning back to the environment an equivalent volume of water that is taken up for water services provision, either through intended or unintended leakage, and also through substitution of supply due to water use. And the second pillar is that we are aiming for energy demand due to increased water production. And this is required primarily for population increase, but also an expanding economy. And we're making sure that this energy demand due to increased water production is sourced from savings in the current energy use levels. Now, this transformation enables water services provision to leave an increasingly lower impact on the natural environment. And in particular, it seeks to reach a neutral approach by environmental and resource benefits that can address the impacts of water services provision. And this leads to a new sustainable way for providing water services. So allow me to thank the European Alliance to Save Energy for the efforts in bringing this discussion forward so as to link energy use and water provision. We take it for granted many, many times, so it's good to actually start discussing this in a more formal manner, because ultimately optimizing energy efficiency of water services is a key factor if we want to ensure our continued resilience to the impacts of climate change and also ensuring the achievement of our targets, particularly that of decarbonizing our economy by 2050, whilst effectively addressing the water requirements of our populations wherever they are. This is therefore an important, if not vital, building block for a sustainable future. So thank you once again for this opportunity, and I wish you all a fruitful discussion, which I will be following for some time, and I will be looking forward also to the different discussions that will be held.
Yes, Minister, thank you very much for being with us. And I know that your support in this and other issues concerning climate change is very, very strong. And we, coming from the Mediterranean area, are particularly, of course, touched by this. And it is absolutely no surprise that you're so committed to this agenda. I would ask everyone, if you can, the speakers, just to put the camera on, so while the minister is still with us, we can have a picture if you are there, because it is not very nice to see the black holes. We will survive also with the black holes. There's no problem, but just it looks nicer. So this is what we learned to do in the pandemic, but you know, that's life. So nice smile, please. Voila. Thank you very much. And I also have, for the people who are listening to us, a little bit of some housekeeping rules. And that is, first, that you will have the possibility to ask some questions to the speakers using the question and answer part, not the chat, but the question and answer chat. Because these are two different things. And please, as soon as you have questions, put them in, because so it will be easier to manage. And of course, the webinar is recorded, will be made available, as will the slides. So now we move on to the rest of our work today. You have here the speakers that will be with us till 11:30. And I just want to signal the presence of Simona Bonafè, who is an honorary member of the European Parliament from S&D, and also an honorary member of the European Alliance to Save Energy. Thank you very much. Grazie, Simona, to be here with us. Thank you again, Minister. And I would like now to go to our two speakers from the European Commission. We are extremely pleased to have the people that in DG Environment and DG Energy are dealing with this question. And we are very glad that they decided to join us this morning and to talk together in this on this topic, because very often in some cases we have that we are all working in silence, and the water and energy is indeed are indeed issues that should not be kept in silence, and the Commission is actually working in that direction, not only with the legislation on energy, let's say, but also on the Wastewater Directive and other questions. So yeah, I'm very pleased to give the floor to Veronica Manfredi, who is the Director for Quality of Life and at DG Environment at the European Commission. Veronica, you have the floor.
First of all, Monica, many thanks. Congratulations to you and to the Maltese Minister for organizing this event, because I think it's very much needed and it is very timely, because we know that we are in a very crucial point in time when across the capitals, plans for the post-COVID-19 recovery are being prepared at a point in time when we know that actually COVID-19 is still not over, and actually news appearing in the news do not make us necessarily particularly happier. But we continue with the determination to build back better. And in this context, I think that the nexus about water and energy has a primordial importance. I think that when the European Commission adopted back in December 2019 European Green Deal, we could have not foreseen how, I would say, central that political priority out of the very well-flagged 6 ones would have really acquired importance. And actually, I would say almost.
Veronica, she's frozen, isn't she? Is it only me who sees her like this, or?
No, he is frozen. Yeah.
Okay. Let's see if she defrozes. Maybe she can take out the videos and eccola, vai.
Is it fine now? Sorry,
yes.
Because I could see myself still in action, but I couldn't listen to you any longer. Apologies for that.
Yeah.
So I was simply saying that with the European Green Deal strategies, I think we have for the very first time a systemic approach that tries to provide answer to what we call the 4 ecological crises that our planet is facing at the same time. It's about climate change, that therefore we need both to mitigate and adapt to. It's about the unsustainable use of our resources. It's about biodiversity loss at a rate which is completely unprecedented, and pollution, so also the public health nexus. And here we see with European Green Deal how much the water and energy nexus actually can contribute to all of that. You know that we have been already in the first year of this college tabling proposals for revamping a much more cleaner and circular economy, which is our reply to try and tackle this problem of unsustainable use of resources. Immediately, I see a nexus with water and energy. We are talking about a more circular management of water, and I'm so pleased to speak this morning in the same panel with Mrs. Simona Bonafè, with whom we had interesting and lively discussions in Council and Parliament in order to adopt the first ever tangible, I would say, piece of circular management regulation of water, the water reuse regulation, such an important piece in the puzzle of an integrated water management, which is at the same time a landmark, but also just a stepping stone, because we know for a number of reasons that we decided to go with that regulation towards promoting a more circular irrigation of our agricultural fields. But I think there is plenty of space for considering whether we could not have a bit more water reuse also in our industrial processes. And this is why, as you said yourself, President Frassoni, at the beginning, in the framework of the ongoing review of the Industrial Emission Directive, that one would not think of immediately as an energy piece of legislation, actually we are very much looking into a lot of energy aspects, including how to potentially promote more reuse of water for across our 52,000 largest industrial plants in Europe. By the way, this provides me with a splendid opportunity to enthuse all panelists, and I see that many of them come from sectors which are extremely relevant for what we're doing in that field, but also the audience, to participate, please, to the public consultation, which is ongoing on the review of the Industrial Emission Directive, and which we run until the 23rd of March. So time for action is now. But also, we saw back in 2019, just a few days before we then also officially adopted the European Green Deal and announced our holistic strategy, that actually the overall water treatment, supply, distribution network, actually all in all consumes over 2%, close to 2.6% of the overall energy produced in the EU. And we saw in particular, when zooming into the Urban Wastewater Treatment Directive, that there is quite an interesting potential for realizing savings. Actually, our work around the revision of the Urban Wastewater Treatment Directive is still ongoing. So I will have to be prudent, but I can reveal at this stage that our analysis seems to point to over 50% energy savings possible out of the way we operate our urban wastewater treatment plants. Not only that, we have also identified the potential for clean energy production out of urban wastewater treatment plants. And I'm sure that some of the illustrations we will see later in the course of the day will point exactly to that, because some of this is already happening across our member states. So what's about looking at our wastewater treatment plants as actually storer of renewable energies and even producers at some stage of renewable energies, and thus direct contributors to, at the same time, cut greenhouse gas emissions by cutting, therefore, unnecessary energy costs, and actually contributing to go towards that much more sustainable way of living and producing that we all plead for. It's also about saving quite a lot of money, because we're talking about yearly expenses in the order of several billions for this water distribution network. So I think really there is a lot of scope for looking at this water and energy nexus in a much more coherent manner. We are very pleased that Malta is actually hosting this meeting, because Malta is, in our eyes, also a front runner when it comes to the way in which they're trying to tackle water leakages. We heard it from the minister herself a moment ago. You know that for us, 2023 date of entering the application across the European Union of the Drinking Water Directive represents a milestone for having provisions there that will oblige our member states and therefore the operators that are in charge with drinking water supply to be much more transparent about the issue of water leakages, and therefore we are confident stimulate better dealing with water leakages across the EU, an area where we know it, we are currently facing a bit of a scandal in the midst of water scarcity. We are still losing every year close to 28% of the water we transport across the EU. So an amount of cubic meters of water which would be enough to satisfy the thirsts of millions of our citizens. So we need to urgently redress this situation. And again, the link with the recovery and resilience funds, the possibility to use that strand as a strand to stimulate water investment that go also into the modernization of our infrastructure network. May I say, we also know that counting only on public funding and of course the efforts absolutely indispensable of our 27 capitals is not enough. But this is why, in parallel, in the European Commission, and of course in close cooperation with our colleagues in DG ENER and in the other relevant DGs, notably DG FISMA, we are working hard to secure that the taxonomy regulation steers the right level of private investment also toward investment which enhance at the same time, and as I like to stress all the time, with the same euro, tick multiple boxes for climate neutrality, climate adaptation, cutting pollution, enhancing biodiversity, and making, may I say, the water operators of the future the hub of the sustainability that we are all aiming for. Thank you so much for having me with you this morning again.
Thank you so much, Veronica. I think that you put a lot of issues on the table, and I'm sure that we will have the chance of being in contact on basically all of them in the next weeks and months. And now I would like to give the floor to Robert Nuij, who is a Deputy Head of Unit for Energy Efficiency at DG Energy. So it's the other DG which is relevant for us today, and he has a short presentation. Mr. Nuij, you have the floor.
Thank you, Monica. I hope you can hear me and see my screen.
Yes.
Great. So thank you very much for inviting me this morning to say a little bit about DG Energy as regards the water energy nexus. I will go hopefully briefly through my presentation, if I can find a way of seeing it, and I'm not anymore. Yes, so are my slides moving?
Matteo?
No, Robert, can you try again, please? Yeah, now yes.
Okay,
perfect.
Okay, so good, thank you. Mrs. Manfredi already spoke about the European Green Deal, which is really the centerpiece of this commission. So I will not say much more about that. You also know why the water energy nexus is extremely important. The energy industry uses a lot of water in the EU. It's not sort of consuming it, it's also pumping water back. Still, it's an enormous amount of water that's being used. And the water sector is responsible for a significant share of the EU electricity. So we believe that it's important to address this, and it will be increasingly important because we can see that water availability due to climate change will also have an impact not only on water use but also on the energy system. And therefore, decreasing water energy needs is absolutely necessary for us to meet our goals by 2030, but also further in 2050. If we focus a little bit more in the European Green Deal on the energy side, we have supplying of clean, affordable, secure energy, and building and building renovation as an important element. And these are sort of the key areas that we are working on in terms of driving this. And I will focus a little bit more on the energy efficiency work that we're doing in the area, and that's relevant for the water energy nexus. I would say there are one thing that we are currently doing is reviewing the Energy Efficiency Directive. We've had an open public consultation on that, and we had specific workshops also looking at energy efficiency in sectors. And there we've seen that also water is seen as an important area for further focus when it comes to the Energy Efficiency Directive. And the second important element there is the Energy Efficiency First principle, which was enshrined in sort of the European acquis, if you wish, and we are now working on trying to operationalize this principle. So how are we doing that? Well, there is, of course, some reference to the principle, and there is even a definition in the governance regulation under which member states have to come up with national energy and climate plans. And the main focus of this principle is to ensure that energy efficiency measures are prioritized as and when they are the most cost-efficient solution. And we are currently working on a Commission recommendation and guidance on how this principle should be implemented in the energy sector, but also beyond the energy sector, for example, for financing and possibly also for the water sector. What do we do? I mean, the aim is really to consider a wide spectrum of energy efficiency measures on demand and supply, and that energy efficiency is taken into account wherever decisions are taken. And this means not only political decisions, but also very practical decisions in terms of planning, in terms of policy design, in terms of investment projects, and in terms of the financing thereof. As I mentioned, not only limited to the energy sector, but also for energy infrastructure, and hence also for water infrastructure. And when I say water, I think it's clear that it's important to continue and to start looking more in depth into this link between energy efficiency and water efficiency when decisions are being made about, for example, investment into wastewater treatment or into other areas such as the separate treatment of stormwater. It was already mentioned by Ms. Manfredi also, the losses are enormous. Losses of water also means losses of energy because the water needs to be pumped and treated. And so this is important to look at. And finally, we will also increasingly look at smart technologies and processes to ensure that these technologies are being brought to bear in this area. Looking a little bit more in detail at the Energy Efficiency Directive, which we are currently revising, from our perspective, in particular, Article 7 is an important article there because it forces member states to have annual savings. Every member state is 0.8, in the case of Malta and Cyprus a little bit less, given their specific position. And we have seen over the last years already that in the context of delivering on Article 7 obligations, member states have taken measures that cover the water sector. And in fact, Malta is one of the countries that has done most in this area. So we, of course, would like the example of Malta to be elaborated upon and to be followed by other member states, because much more is possible. And we also have articles that deal with the energy audits. So far, this is very much focused on sort of energy, but also here, the water sector could do much more according to us. The directive also covers, for example, information to consumers about the use of domestic hot water, and that's also very important to raise awareness. And when we talk about awareness, an area that's often sort of forgotten in this field but plays a very, very important role is what we do on eco-design and energy labeling. You will hopefully know that the energy label changed in the beginning of March this year, where we removed the +++ classes from the label in the hope that it's becoming more effective. And we have measures in place for washing machines, dishwashers, pumps, circulators, motors, which drive an enormous amount of energy savings already, almost in a sort of hidden way. And we are also continue to work on things like taps and showers, high pressure cleaners, and electric kettles to try and see whether in those product areas we can also drive further savings. So This is sort of a brief overview of what we in DG Energy are currently doing and will continue to do to make this link between energy and water, I would say, more tangible in the legislative and other initiatives that we are driving forward. Thank you very much for your attention.
Thank you very much. I think that this, and we didn't doubt, of course, both in the case of Madame Manfredi and of Mr. Nuij, open to us dealing with these questions, two issues. One, that there is a readiness, let's say, to deal with this question that probably was not there before, not for ill will, but simply because times were not right, perhaps. And so this, you gave us really very, very concrete hints about where our priority in explaining and in talking about this question should go, and second, which are the potential really that this happy marriage, let's say, could lead in both in DG in energy legislation and in water legislation. Okay, I would like now to go to the more concrete part of our work, which is indeed to show what is done now. You talked about the need to have, you both actually talked about the need to work with the private sector. I think that that is absolutely true, and there is a part of the private sector as well, at least, that is ready to go, and that started even before the legislation comes, but of course we need to scale up and to make it even more systematic. So I would like now to start the second part of our meeting, which is very rightly entitled, and I want to read it again so that we know where the framework is: Realizing the Water Energy Nexus, Case Studies to Support Current EU Policy Implementation and Future Policy and Regulatory Development. We know that implementation, above all in these issues, is the most important problem of the European Union legislation. And I will start then by Jure Sumi, which is the Group Brand Manager and Green Solution Advocacy Lead from Knauf Insulation. And he will speak about stormwater management through green infrastructure to save energy and cost in wastewater treatment facilities. You have the floor, Jure.
Thank you. Let me just... So I hope you see the screen.
Yes, we do.
Okay, so hello everybody. So I remember, as it was already mentioned, you know, we had similar discussion 3 years ago in Malta in 2017, and I believe that there are some things which were already happening in the last 3 years when it comes to stormwater management and green infrastructure. If I go further to the benefits of green infrastructure, I mean, going back to Ms. Manfredi mentioning, you know, €1 building a lot of benefits, we can see the green infrastructure has multiple benefits for the environment, for the people. But I will focus today on stormwater management, which is at the moment or currently the most seen benefit by at least European Union or its municipalities. So how come or how can green infrastructure actually support the water energy nexus? So when you're building a new building, usually what you do, you go on the ground, you demolish the green space, you build up something, and actually what you do, you seal off all the land in order the water cannot escape into the ground and later evaporate. So what we need to do is to make sure that when something new is built, actually we make this new green immediately, because if you do that, you basically replace whatever you demolish when starting the building. You actually do the green part on top of the roof, making sure that all the stormwater which comes from the clouds is captured and retained and evaporated. So with this, you actually, what you do, you re-establish the water cycle, the natural water cycle, which could be demolished by intensive urbanization. So I will just focus now on two case stories where actually municipalities and some countries already think how to implement green infrastructure into the new builds. So, for example, you see on the screen, you see a big shopping mall which was built in France, and there was a requirement from the local municipality that if you want to build that, you need to re-establish the stormwater cycle, so the water natural cycle. So just by implementing green roof on top of the building, we are actually, or the commercial establishing is preventing more than 60% of water, stormwater, to come into the sewage systems or the stormwater system. This means the water which stays on the roof, which would go into the sewage system and there will be no green roof, will actually save a massive amount of energy for this water to be cleaned. So if we make sure that the water stays on top of the roof, this will mean this water will evaporate, it will re-establish the natural water cycle and will never come to the sewage treatment plants. So the two benefits, energy efficiency, and when the big storms come, it's even worse when it comes to the flooding of the sewage system. The sewage system, so the wastewater cleaning facilities, sometimes they cannot cope with all the water coming at the same time. They need to open the safety wells, and all the sewage and storm water goes directly into the creeks and rivers, polluting them. Just for this facility, we have done a quick estimation. Just for cleaning the storm water, which now needs not to be cleaned, we could save in a year 2.9 megawatt hours of energy, which is, one building, which is pretty decent, I would say. If we go further, this is an example which we did a few years ago, actually not few, last year ago, but planning for the last 2 years, is something where we want to implement an educational green roof on a school in Slovenia, where I come from, which is basically a roof which on one side, it captures the rainwater as the one you have seen before. But at the same time, we also implemented a special system which is really reducing the amount of water going to the sewage system. So if you can imagine that climate is changing a lot. So you have these long rains or really short rains. So the major negative thing from civil engineers was always that green roofs do not detain water. So when the green roof is full, like when a cup is full, it will, still the water will go through into the sewage system. You will need to clean it. But, the new system developments for green roofs are actually implementing green roofs who are able to control and lower the speed of water going from the roofs into the sewage system, which also means that this water comes into the sewage only after a certain time when the storm is over. So the sewage treatment or stormwater treatment plants can easily handle this by not implementing the additional capacities, which means no extra, super extra energy is needed for this kind of cleaning. So these were the two examples, just showing that implementation of green roofs is really handling the stormwater, preventing the stormwater to come to the facilities to clean the stormwater or sewage. So there are plenty of legislation which is currently ongoing or being reviewed. So I would just point out the first one is Urban Wastewater Treatment Directive, where so far there was no mentioning of green infrastructure as a way to handle stormwater or limit the inflow of water into the sewage system. So this is definitely something where we need to do more in legislation. The new one is definitely Energy Performance of Building Directive. This is another good aspect. Then we have Biodiversity Strategy 2030. We have seen the first drafts, which are now in the parliamentary procedure. We know that green infrastructure has been implemented, urban green infrastructure has been implemented already. Then we have Climate Adaptation Strategy, which was announced or adopted last month. And we are happy to see that a lot has been pointed out in terms of green infrastructure. And of course, new EU Bauhaus initiative. I was just last 2 Fridays, we had open calls with new EU Bauhaus initiative, people getting together, sharing the idea. You could actually see the enthusiasm of the regular people and academia, where they see green infrastructure as one of the cornerstones in order to support our cities to become better, more energy efficient, and more green. So still plenty to be done, but has been done already a lot in the last, let's say, 2 to 3 years. So we just need to progress with this. That would be.
Jure, I have a question for you. First, can you switch on your video, because
I'm not. Yeah, I will try to do that because I'm connecting through the web browser, not through the app. So I'm not sure whether I can.
But anyway, I just wanted to ask you one question. You indicated in a very effective way the legislation where you could see certain improvements there. I just wanted to ask you because I'm curious, and then we will have other questions later on. But what is the situation in the European Union for what you know in terms of implementing urban green infrastructure? Is it going on? Is it something that really needs a European push, or not?
Yeah,
just briefly.
I think that what European Union would need to do is, of course, to properly implement green infrastructure as cornerstone of all major legislation. But at the same time, I think European Union should promote green infrastructure through the public buildings. Putting the green infrastructure on the schools in order to, first of all, tackle the climate changes, saving energy. But it's also amenity space where the kids could actually learn, teach. I mean, the school which I showed is actually also outside class on the roof. Then it's health establishment and office buildings from the governments, municipalities. I think we need to show, public authorities needs to show that this is mandatory or this is nice to have, not just nice to have, that this is effective to have. And when the commercial players will see that, I think they will follow as well. So I think we need to drive to show publicly to show that green infrastructure is necessary to have.
Okay, thank you very much. And now we move to the second speaker, and that is Mats Warming from the Global Segment Director of Water and Wastewater from Danfoss, and he will speak about an energy-intensive wastewater treatment plant turned into energy producer. Yes. Please, Mats, you have the floor.
Thank you. I hope you can see my screen.
Yes, we can.
Yes, super. Referring back to the previous speaker, I can only agree to the figures about that the water industry is using a lot of energy. I think the figure was 3.5% of all electricity used in Europe. And that both have been talking about leakage. Reducing leakage also means that you reduce energy consumption, as well as there have been talk about that the wastewater facilities in fact can be energy producer, and that's exactly what I would like to touch on with this case. I will not go too much into the technical things, but we have had over the years a very close cooperation with utility in Aarhus in Denmark, which is the second largest city in Denmark. And what is interesting is that it is, as you can see on the pictures, if you look pictures here, a traditional activated sludge treatment plant. So it is like probably 80% of the facilities are in Europe. And if we were looking at the water supply, then it's based on groundwater, which I think 60% or so is in Europe. So it's a very traditional water cycle, I suppose, on the drinking water side. On the wastewater side, it's not new build, it's an old facility, and it's covering around about 200,000 people. The other thing which is important to understand is that this catchment area for 200,000 people, which they have made energy use, and I'll come a little bit back to that, but there is no windmills, there is no solar panels, there is no heat pumps, there is no sludge from other facilities, there is nothing from the food industry, the sludge is not burned. And it's not because we have anything against windmills, not at all, we love them. But what is super important to understand is that this can be copied. So it's basically household wastewater and traditional drinking water supply. So there's no tricks with any energy coming from outside or any slots coming from another facility or anything of that. And if we look a little bit at what they have achieved, then if we take 2018, and it's fluctuating as real life is, it will fluctuate a little bit up and down, but they are still on roughly the same level. They were, for these 200,000 people, they were using 4.1 million kilowatts on providing drinking water. They were using 500,000 on transporting the wastewater. They were using around about 3.3 million on treating the wastewater, and you can see to a pretty good level. So there's no cheating, not removing nitrogen and phosphate. All in all, around about 8 million they were using for these 200,000 people. They were able, out of that wastewater facility, to produce 4.6 million. They were able to produce a surplus of 1.9 billion in heat, which means that they were at 6.5 million. And that means that they were at 82%. They were very close to being completely energy neutral. They had a wastewater facility producing 196%. That means 96% more energy than the wastewater facility itself needs. If you just look at pure electricity production, because not every country can use the heat surplus, then they were on 150. That means 50% more energy than is needed for treating the wastewater. If we look at the 2060 figures, they were in fact in plus so that means that they had all the energy they need for the wastewater facility, and they had enough surplus of energy that they can also pump the water into the city, can pump the groundwater up, they can pump the wastewater. So this is a case on where you, for 200,000 people, in fact can make the whole, both drinking water and wastewater, energy neutral, or just at the balance at least, and that you can convert wastewater facilities into energy producers. And I think what is really key here is that what have been done to this facility. So it's super important to understand it don't need to be new built facilities. This is our old facility. I think it's 30-40 years old, and it looks like the major part of facilities does in Europe. What have the key elements? The one have been a tremendous lot more real-time sensors, which basically is what when we talk digitalization, that's usually what is going on. A lot more sensors combining different sensor signals in different ways. They of course use highly efficient components, as I think there was a talk about also, and then they have full-blown what we call controllability. That's we have our speed drive and so on, so that you really can adapt to the changes which are in the water industry. And if you combine these with real-time process control, then you can gain these things. And we were looking into where were they in fact gaining all the improvements from. And 70% of all the improvements they have gained is coming from process control, but holistic process control. So it's not only about, which is good, to have motors which are more energy efficient. So that's a good thing, and it's nice that there's regulations coming there. The point is that it on a 110 kilowatt motor, it moves 1%. Now here we are talking about 70% is moving on the process control side. So I think we need the component savings. They are around about 30% of the whole savings they have achieved. But we certainly need to have some regulation which is pushing on utilizing all this energy embedded in the wastewater, and at the same time looking at reducing the leakage, because they would never ever get to this point if they don't have the leakage. They have a leakage around about 6% or so, and if they have had a leakage of 30%, they would use far too much energy on the drinking water side. So we really need somebody to push more on how can we utilize this. This is a case on that it's possible in practice. It has been working for 5 years now. We have 3 or 4 other facilities in Denmark roughly doing the same. We see US, Chicago picking up on it. We see the Dutch picking up on it. So it's slowly moving, but I surely think we need some regulation to move forward. I could add to it that the Danish government, based on this experience, have made a decision that they want that Denmark become on the water side, both on drinking water, wastewater, small facilities, big facilities, completely energy and climate neutral in 2030. So worthwhile looking at. We have got a couple of innovation awards. I'll not spend too much time on it. This case I have shown here was mentioned also in that reflection paper the European Commission made, I think last year. And then this case have also been selected in the Solar Impulse Global World Alliance, as you maybe know of, where they are trying to find the 100 most clean and effective energy solutions. And to that, I should maybe say that the investment they have done here on this facility had a return on investment which were 4.5 years. On the process control part of it, which was the one I was showing here, the 70%, it was round about 3 years. So it's a good case on that. It's not only a question about being green and doing some things for our water environment and for the climate. It's also, in fact, a good investment. And it's even probably in the major part of the European countries a better return on investment than we see here. I know the electricity prices, which are the key here, in Denmark is lower than, for instance, they are in Germany and a lot of other places, and Italy and so on. Italy have roughly the double price of what we have in Denmark. So with a double price, you will have an even better return on investment. So yes, I think that was the words. Monica?
Yes, I'm talking to myself. Can I just ask you a very quick question as a follow-up? First of all, I think that one of the issues that we also in our conversation have to very much underline of what you said among the very interesting things is this issue that the saving come from the process, you know, and not only from the technology. That's really key, because yes, in the industrial process is different than, of course, the different specific technologies, and sometimes the two things are mixed, and the potential of both are actually mixed up. And sometimes this is really not conducive, because we're not speaking only about single products, but we are really talking about the whole industrial process that makes a difference in some cases. So I think that was a very, very important point. I would like to ask you if you had, you talked about the prizes, but if you had interest in other countries, because you are a multinational, so you are active, very active in other countries as well. And I wonder if there is a interest for this concept beyond your own country, and if you are able also to think ahead, what is the next step? Briefly, and then we move to the next point.
Yeah, so first of all, yes, we have seen a lot of interest around the globe. I will say California have picked up a lot and in a process of copying some of this. Chicago, similar in US. We have seen China have interest in it, so there have been a lot there. In Europe, we have seen the Dutch people looking very much into it. And I see also, for instance, in Germany, it's beginning to pick up, but there is a lot of potential still to go for. Looking out, what is the next big step, and what I will tell now is it cannot be applied in all countries, but what we have been a little bit surprised about, in fact, is that if you have district heating, if you're using district heating, then it have proven that to have heat pumps on the outlet from wastewater facilities is a super good thing with super high efficiency, because the temperature is higher there. So you use the energy again embedded in the wastewater facility. And it's attractive because the wastewater facility are close to the cities. The Denmark case show that we, based on that, can make a carbon neutral heating of 20% of all household in Denmark. 20% of the total household consumption. That is really big figures. Yeah, that's massive. And there is a tendency to expand district heating systems in Europe. And if that happens, then at least the places where they do and where they already have it, they should consider that. So that's one of the other things. And that means really that the places where you can, besides what I have told, everybody in my view can do the first part I told here, that is to get wastewater facilities to produce more energy than they need, and then lower the leakage. And on top of that, the ones who have access to district heating, there is a super great opportunity to utilize the thermal part of the energy in the wastewater. And it's already implemented, by the way. There's a couple of Sweden have done it for some years. Denmark is doing it. There's a major project in Hamburg on the way with a super big heat pump, so it's already on the way.
Thank you. Since I come from the very, very few cities in Italy with district heating, which is called Brescia, this could be an interesting thing to think about. Yeah. Okay, so thank you very much. We move then to our third speaker, who is also the chair of our water working group in the European Alliance to Save Energy, David Martin, which is VP and country manager in Belgium and France of Ecolab. And he will talk to us about water savings and energy efficiency in the high-tech industry, a very to the point. David,
thank you, Monica. Can you hear me? Can you see the screen?
Yes,
all good?
Very well. Everything is smooth.
Okay, so good morning, everyone, and thank you for the opportunity to give an additional perspective to the great presentations that have taken place a few minutes ago. I'm going to talk about high-tech industry, and I'd like you to think through smart water opportunities within the high-tech space. When we talk about high-tech industry, typically this includes data centers and microelectronics, and here I'm going to try and center the conversation more specifically on data centers. Digitalization is a great way to save energy. As well, it does consume quite a lot of energy and water, as we all know. You may not be surprised to know that the amount of data that is going on right now is significant. I think my notes are correct. Over 500 million tweets every day, 250 billion emails. I mean, these numbers are significant, and huge numbers as well of internet searches. It's estimated that this is going to grow by 50-fold in the next 10 years. And that basically means that the storage requirement will need to increase by 40% every year. So let's say that the high-tech industry is particularly relevant for the discussion we'd like to have today. So just before I go into the case study I wanted to share, I just wanted to briefly introduce Ecolab. We, as a company, we are focused on making the world cleaner, safer, and healthier. We work with the industry, over 40 industries, from pharmaceuticals, from restaurants to hotels, hospitals. We try and drive efficiency and allow our customers to operate more efficiently by optimizing water and energy use, ensuring safe food and clean environment. And just as a point around clean environment, we're particularly focused on infection prevention. So we are very proud, and I would say feel a very high sense of responsibility as we are engaged with hospitals and vaccination centers in order to help and fight the current pandemic that we're all facing. So as a wrap up, we are looking at ways to help our customers to basically do more with less, and growing their business responsibly. Obviously, no other way can it be done through sustainability and innovation, which is at the core of what we do. So that was a little bit the intro on the company. And as I slowly get to the example on data center, I wanted to give you as well a bit of a global picture on how the impact we've had through helping our customers, the industry, to save water. And so in 2020, we've helped our customers reduce their water consumption by just under 800 billion liters of water, which connects to a significant amount of energy, as indicated on this slide, which naturally you can connect to greenhouse gas emissions. And I think the point I wanted to make here as well, and I think one that was made a bit previously as well, not only is there a link between water and energy, but water efficiency, energy efficiency drives competitiveness of our industry, and naturally, particularly here in Europe. So as I go into the example I wanted to share here, this was one of the data centers. And as you may know, in Europe, we have just under 400 data centers to date. And this data center is a data center linked to a research center. And when you're thinking data center, actually about a third of the energy used in a data center can be connected to water, typically to the cooling system, about, I would say 20%, and about 10% to what is called CRAC, which is the computer room air conditioning system. And so in this example, the municipality was requiring the data center to use recycled wastewater. And using wastewater, one of the challenges that comes with that is that the quality and the types of and the quantity of contaminants present in the water makes it more challenging to manage the cooling and the air conditioning system. So, and which eventually leads to having to reduce concentrations of water and having, let's say, fouling, corrosion issues that are reducing the energy exchange with the process, i.e. the computing technology. So what we did here is that we implemented one of our flagship innovations, which is called 3D Tracer, which allows to model and analyze the types of water and the fluctuations of water flow and quality, and determine the optimum technology to ensure that the usage of water doesn't impact the process, and allows to as well concentrate to the maximum the actual cooling system. And so by putting in place this technology that has digital elements to it as well, this allows to have a permanent monitoring 100% of the time and maintain the right level of quality within the systems. And additionally, the information received or used to properly adapt the treatment on the water side has been connected as well to the process, i.e. the computing that is taking place in the data center. Typically, the major KPI to run a data center is called the PUE, which is the power usage efficiency, which basically means you look at the quantity of energy that comes to the data center over the quantity of energy which is used for computing technology. And basically, the lower the PUE, the more efficient you are. And so in this instance, what we've done is that we allowed to increase by 10% the cooling efficiency, which allowed to reduce the PUE from 1.7 to 1.65. And that in turn led to a water saving of just over 10 million liters of water per year, and as well an energy saving of just over 550 kilowatt hour of energy per year. And that's a very concrete, hopefully pretty straightforward example to explain how better managing water helps to better manage the energy, and at the same time make the industry, and in this instance the data center, more competitive. So as I wrap up my few minutes here, I just wanted to conclude on a couple of points. Industrial competitiveness, and one of the tools that we could think about and that we would support is the EED as an enabler to even leverage further the water energy nexus. I would say many multinationals today are aware and understand the connection between water and energy, and therefore can identify energy savings, cost savings, which not only has a positive impact on the environment, but as well on the bottom line. And there is a tremendous opportunity to expand that as well to the small and medium-sized companies in Europe. And by doing so, enhance the EU industrial competitiveness across the board. And so EED is, we would believe, a very adequate tool to help and enable that. Not the only one, but one that can help that. We see that the EED in Article 7 is a great opportunity to educate these companies on the opportunity to improve their business and help count toward energy savings target. And maybe what is needed is an incentive scheme at member state to bring this to the attention of companies and plants. And I think hopefully today, by having this workshop, that's a great way to illustrate examples on how that can be done. Thank you.
Thank you very much, David. I see that we are having the questions ready, also not only asked but also answered. So this will save us time because we are a little bit behind schedule, but we go on. And I would like now to give the floor to Alexis de Kerkhoff, who is a Director Marketing and Business Development for Water Utility in Ecological. And he will talk to us about digital solution enable new level of energy savings and asset optimization in water management. Alexis, you have the floor. Alexis, are you with us? Hello, hello.
Yep, can you hear me now? I was on double mute, apologies for that.
Yes, please go ahead. 5 minutes.
All right, so thank you very much for this brief introduction. I believe that you see my presentations right now.
Yes,
as you introduced me, I am Alexis de Kerkhoff. I lead the marketing and business development at Xylem for Europe. And I really appreciate the time that you're giving us today for addressing this important topic. As mentioned, we want to address how digital solutions are truly becoming enabling technologies today in the water sector to first address energy saving, but a lot of other challenges that we are facing in how we are managing water today, both water supply and water sanitation. And you will see that the case that we are presenting here today are very complementary to the previous cases that have been discussed so far about green infrastructure, about process management, or even machine learning or data intelligence within the industry. So before hitting there, we want to understand above the high level picture, what are the true realities today of our water services? And we understand the pressure that we are dealing with climate changes of more and more frequent weather events. But in addition to that, we need to be aware of the critical challenges of an aging infrastructure. And the Drinking Water Directive has already taken a huge step forward in addressing that by monitoring water losses. But we also understand that our citizens are under a lot of pressure, economic pressure, and it's a huge burden on the taxpayer to also address water infrastructure and updates or growth of our infrastructure, we understand that public health is becoming more and more critical, especially in the last year and a half, where the pandemic has hit us all, and understanding of how we can use water as a tracer is critical. And then within the water sector, we understanding that there is a very much aging workforce, and the transition there is getting critical as we are facing the availability of new technologies. When we look at the industry right now, we are facing a very difficult status quo. The status quo is that we are investing billions into infrastructure for water supply, sanitation, stormwater management, and it always requires more because of the challenges that I was just mentioning before. The problems underlying there beneath is the fact that we are maintaining those heavy investments in conventional gray infrastructure. And that adds huge heavy pressure on the taxpayers and local governments. It is critical to address this. The picture that you see here is the Tideways Thames channels, which is about a €6 billion investment in London to manage stormwater underneath the city. That structure is huge in terms of investment, but environmental footprint, energy use for the management of the draining of stormwater there. So how can we, together with public policy, advance to the next generations of infrastructure, both for reducing the cost that we have in providing such services, but also making them more sustainable, reducing energy use, their footprint, and improving the management of water. When we look at the entire water cycle represented here in this diagram, we understand that we are stepping forward in the availability of new technologies, smarter technologies, digital solutions as introduced by Matt and David. And those solutions are yet to be fully used to the highest potential within the water cycle. And the benefits that we always call higher performance, better efficiency, and so on, are actually very tangible, that I would like to highlight here under capital savings, and I will have a case story in a minute about this. Operating efficiency, both for energy use, but also in terms of like labor efficiency to focus on more active or efficient tasks for the labor. Affordability, public health, environmental quality, and resilience. Resilience, we're discussing this for critical infrastructure recently, and it is important to address it. I'll go through 3 case stories here very briefly, and I know that we are a bit short on time.
Thank you.
The first one that I'd like to highlight here is the use of digital real-time decision support system. It's a very complex term, but basically it is the utilizations of artificial intelligence to sense, using sensors within the system, the treatment plant, predict by learning historical behavior of the processes, and take decision or support the operator in taking decisions and tracking those decisions over time. The case story here happening in Germany, in Cuxhaven, has led a saving of 26% of energy use in the biological treatment of this wastewater treatment plant, which resulted in about 1.1 million kilowatt saving annually, or an equivalent of 330,000 euros per year. So in perspective, it brings up a huge potential. If you combine this to the results shared by Matt from Danfoss, imagine the potential of truly making that plant 100% energy positive. The second example is applying the same artificial intelligence on the collections of wastewater and stormwater networks. So it's similar to the one built in London. But instead of stepping forward in gray infrastructure, we use blue infrastructure. This blue infrastructure is the digital, the artificial intelligence. Through the same step, sense, predict, and act, there is an opportunity to combine the hydraulic volumes of those networks, make them work together, and save up to 70% of the initial investment planned into gray infrastructure, into civil work or concrete. This, in this case, it's a case in the US. Out of a 1 billion project, the AI project saved up to 600 million euros out of it. I will skip the last example just because I think that you all understood that the use of efficient equipment and technologies helps cutting down also related emissions. My colleagues have been, my colleagues and peers in the sector have already been discussing this. So I'd like to go to my concluding messages. That today we don't need to replace infrastructure. We don't need to build new or more. We need to modernize. The modernization is critical to move forward in better conduct water energy nexus and stretching limited infrastructure with limited capital investment. So the technologies are allowing us to leapfrog past underinvestments, which are today failed in the failing infrastructure that we're having, not sustaining the needs. But we also urge any legislations addressing water to truly incentivize the adoptions of those digital solutions. The same for green infrastructure. Blue infrastructure truly needs to be adopted through the legislations, and I'm happy to discuss any arguments on how we can support or help having those legislation addressing this. So thank you very much for the time here today. I'm happy to take more questions.
Thank you very much, Alexis. Unfortunately, we are really running out of time, but I think that also the messages at the end of your presentation are extremely clear. And I'm sure that there will be time and possibility, if necessary, to come back. And I come now to the last intervention of this important, very concrete part of our work. And I would like to give the floor to David Sacco, who is the manager of desalinization services of the Water Services Corporation in Malta. And he will talk about applying the water energy nexus in the provision of water services. Mr. Sacco, you have the floor. Mr. Sacco, you hear us?
Yes, yes. Just presentation.
Suspense.
Can you see my presentation?
I think you can start because they take some time, but you can start.
Can you see my presentation?
We don't yet, but if you don't mind to start, because it says that you started the sharing, so it will take some time.
Okay. So my presentation level. As an introduction, in Malta, groundwater is the only natural resource. This natural resource was enough to satisfy the demand till mid-60s. As the demand increased, other production facilities were necessary to augment this natural resource. Distillation plants were commissioned until membrane technology emerged in the late 70s. 5 seawater RO plants were commissioned between 1982 and 1992. However, the demand was still not satisfied, mainly due to the leakage in the network. WSC embarked on a heavy leakage program to reduce this leakage, and now we have decommissioned 2 seawater desalination plants because they were no longer required. At the moment, we are operating with 3 seawater RO plants and having a blend of 60-40, 60 RO water and 40 groundwater.
Okay, now we see your presentation.
Okay, so with such a dependency on desalination, energy efficiency became a priority for the Water Services Corporation. What have we done to improve this efficiency? All right. The first thing we've done was to carry out an energy audit to identify areas for improvement. Concurrently, we also changed the procurement policy, the policy to select equipment. Before, it was based on capital, CAPEX, but we changed it to and introduced the whole life cycle cost, okay? Because this gives importance to the energy efficiency of the equipment. So this was very important. This change in policy helped us identify more energy efficient equipment. We replaced the energy recovery devices presently installed in these equipment. Before, they were reverse running pumps with an efficiency of around 78%. We replaced them with isobaric devices with an efficiency of 97%, which was a great improvement. We also replaced the membranes. The membranes at the time were hollow fiber membranes operating at a pressure of 82 bar. These were replaced by spiral wound membranes operating up to a pressure of 69 bar. Again, a significant decrease in operating pressures. We also installed variable speed drives to match the pumping equipment with the system characteristics, because we found out that we had a lot of valves throttled along the process, and this was leading to considerable amount of energy lost in these valves. More importantly, however, we developed an in-house SCADA system to control the whole process. So this SCADA now is programmed in a way to control the whole process. Once a system is commissioned, the parameters, the optimal parameters are entered, inputted into the system and are used as benchmark by this automatic system. So this SCADA system controls the operational efficiency of all components within the system. It also conducts online energy audits. So if any parameter is out of spec, this system will alert the operator to do something and act accordingly. If the operator does not act within a set time frame, then the system is programmed automatically to take over, and it may eventually also stop a particular system and operate a standby system, which is deemed to be more efficient. So over here, we're seeing, the use of artificial intelligence to control the whole system. This also controls the efficiency of equipment which is being maintained. So if a pump is serviced in our workshops and this is then back in service, if the efficiency is not up to the design level, this system automatically notifies the operator to recheck, dismantle, and maintain again. So this is very important tool to control the energy consumption and hence control our operational costs. All these initiatives has resulted in a drastic decrease in energy consumption from 7 kilowatts to 3.8, which is nearly half the energy consumption that we had before. In 1995, the energy consumed was around 219 gigawatt hours, 20% of the national demand. Now we are at 8.8% of the national demand. Next slide, please. Now we are moving from, we're using the same concept, okay, because the reduction in RO energy has placed an increased importance on other sectors of our service provision. We are also focusing on other areas. For example, groundwater. We have a number of sources, groundwater boreholes. So we are focusing on getting the same amount of groundwater, however, from a spatial area, hence improving the quality of the water. Improving the quality of groundwater implies we need less RO water, hence the energy is reduced for the blend. Again, reducing unnecessary pumping pressures is a very important aspect in our distribution. We have some main networks which also are connected to consumers directly. This will increase the pressure, especially during the night. So we are now having dedicated networks to transfer water, especially from RO plants directly to our main reservoirs, hence reducing friction losses and also reducing energy costs. Seawater intrusion in our wastewater network is another issue. Around 10% of the water in our sewers is seawater intrusion because part of the network is under sea level. So we're tackling this to reduce this influx of seawater. Also, we're improving the energy efficiency at our wastewater treatment plant by introducing the same principle that we have in RO plants, the SCADA systems to control and acquire data and manage the process automatically. We're also increasing the energy recovery from biogas generation in the wastewater treatment plants. We also developing a system whereby what we have achieved in our water plants is also replicated in our services, in our whole services. So we are looking at the production side, we are looking at the distribution side. We are predicting the demand, and this tool that we are developing will help us to decide which sources to operate and how we manage the whole operation in order to reduce the operational cost and the energy consumption of our operation. In conclusion, if we look at the slide, I mean, you can see the reduction in energy consumption in the last 25 years. In 1995, we had a consumption of a specific consumption of around 23 kilowatt hour per cubic meter. This was reduced by reducing the leakage. The leakage of the network was reduced from an ILI of 19.95 to 1.87, and the RO specific energy was reduced from 7 to 4 kilowatt hour per cubic meter. So the significant reduction in energy requirement per cubic meter consumed was achieved mainly through the water demand management, okay, because as has been highlighted, every cubic meter saved is energy saved, and also by improving the energy efficiency by reducing the energy required throughout the whole process. So our vision is to keep reducing this energy used for our processes by operating on the comprehensive water cycle, whilst continuing to emphasize on water demand management at all levels. Thank you very much.
I am talking again on my own. Thank you very much indeed, Mr. Sacco. I think I actually wanted to know to ask you how much energy we're saving, but you answered the question, so it's perfect. Now I would take advantage of the few minutes more than Madame Bonafé can stay with us to ask if briefly Veronica and Robert would like to come back to some of the points. We will go on, you know, having contacts, etc. But just if you have a couple of issues to touch, thanking again Simona for her patience for these conclusions. Veronica, ladies first.
I'll try to be super brief because we're really running out of time, and the important messages from me are coming naturally from all this presentation, and maybe also in particular this very last one, where we see that in order to get there where we want to be, we have to work on all the pillars, reduce the demand. So this makes the point about water efficiency also, but not only in our households. And I think it opens the long-standing debate about the right price for water, and water being charged in the right manner across all the users. Today, I think we are disproportionately letting pay the consumers, the individual households, industry to some extent, but maybe not everyone else who should pay for it properly. The pollution levels, how much by basically cleaning our rivers, our seas, our groundwaters, we reduce the need for treatment, and therefore we become more efficient. I hope that the Zero Pollution Action Plan that the Commission is determined to table before the summer break, and around which we will organize the entire Green Week this year, please come, 31st of May, 4th of June, will entail a number of practical measures to really implement what the treaty tells us to do. Prevent at source, and remedy and clean up as much as you can. And last but in no way least, of course, unity with the colleagues in the GN who are carrying out an immense work to improve energy efficiency. Also, we didn't mention it so much in our households, with the renovation wave and all the work around the European Bauhaus. I believe into this. Thank you.
Thank you very much indeed, Veronica. Robert.
Yes, thank you. Well, I mean, very briefly, I'm very impressed by the presentations, by all the sort of ideas and things that are already happening. And sort of a question really, rather than a comment, is, so how can we, from a policy perspective, support all of these measures and solutions that are already out there? It was a question also asked in the chat I saw, and I would be really interested to see whether there are sort of concrete ideas about how we can support. We're in the middle of the revision of the Energy Efficiency Directive, the Energy Efficiency First Principle implementation, how we can contribute to bringing more of those existing solutions to the market. Thank you.
Thank you very much. Mats, I see that you raised your hand. Unfortunately, we are running out of time, and we will promise that we will organize next meeting a little bit longer, because I see that there is a lot of space, and we are coming back on this. Actually, the real goal of this event was to flag certain things and to put together concrete examples. And by the way, we already have a publication in which some of these concrete examples are listed, and we are working together with you also to put in connection, let's say, the legislation, as you asked Robert, notably on the upcoming directives that you are very hard working on, I think. And the same thing goes, of course, for Veronica. We will be in touch, not excessively, but a little bit, in order to I don't know if you help, but at least to give a contribution from our end. And now I would like to give the floor to Simona Bonafé, who will make some conclusions, and who is also an honorary member of the European Alliance of Energy, and of course, a very, very well-known member of the European Parliament, active in these issues from S&D. Please, Simona.
Thank you, Monica. It's very difficult to conclude this event. A lot of things has been said. I will try to define some flag points. And as you have said, we will come back with other events on such topic. And first of all, let me thank you, Monica, the president of the European Alliance for Energy Save, and for organizing, of course, this event. And I also want to thank Miriam Dalli, my former colleague in the European Parliament as minister, new minister, the Maltese government for co-hosting this meeting. It has been a very important discussion today on the nexus between an efficient water management and energy production and their interdependency. And from the different perspective that every speaker has underlined from its particular point of view. And I think that this topic is becoming more and more a subject of interest, of increasing attention for scientific, but also, let me say, for policymakers. And it's correct to say, as Veronica said before, that time for action is now, because we need to start now to design again a new paradigm for our economic model after the pandemic. And this model cannot be, can be more resilient, more sustainable. Let me say in one word, needs to be resource efficient. That's why today's discussion is really, really important. As we all know, and we all have said, the EU has set with in the Green Deal the ambitious goal to become first carbon neutral continent by 2050 at the latest, which will require to all stakeholders, and I'm very happy that today we have a lot of these stakeholders around on the table. But we need to, it requires, this ambitious goal requires that all stakeholders can act together and can discuss together for a long-term action plan. Coming to our, let me say, to our today discussion. So water is used in the energy industry for producing fuels, cooling thermal power plants, and generating electricity in hydropower plants. At the same time, we can say that the water system needs energy for collecting, pumping, treating, and desalinizing water. So water availability is among the key constraints affecting the European energy sector, which currently requires a big amount of fresh water, as it has been said, similar to the water needs for agriculture. So achieving the decarbonization of the energy system could reduce its water needs by 2050. That's why decarbonization of the energy sector faces us challenges, as all of you have said. And not every technology has the same results in this decarbonization. So in particular, we should make an analysis over the technologies used to achieve carbon neutral energy transition, which could, if not properly managed, increase water stress or be limited by it. Let me say some examples. Some low carbon technologies such as wind and solar photovoltaics requires very little water. Others, such as biofuels, concentrating solar power, carbon capture, utilization and storage, or nuclear power are relatively water intensive. On the other side, according to the International Energy Agency, over the period by 2040, the amount of energy used in the water sector is projected to more than double globally. So the largest increases comes from desalinization, as we have heard, followed by large-scale water transfer and increasing demand for water for wastewater treatment. However, this is significant potential for energy savings in the water sector if all the economically available energy efficiency and energy recovery potentials are exploited. Wastewater, for example, contains significant amount of embedded energy that, if harnessed, could cover more than half of the electricity needs of municipal wastewater utilities. Another way to increase efficiency is to reduce water losses, which would save water and energy. So the greatest potential lays down in fully extending the circular economy principle to the water resources, as it has been said. In order to increase water efficiency and save energy, during the last mandate, European co-legislator adopted a new regulation on minimum requirement for water reuse, as Veronica Manfredi said before, and enter into the details of this piece of legislation, and I would not say more on this point. The new law, in any case, what is important is that the new law has set minimum quality standard for reclaiming the water to be used for agriculture irrigation. And it also sets out obligations for production, distribution, and storage operators, as well as risk management measures that are very important for the topic that we are dealing with today. So through this legislation, EU could potentially reuse nearly 7 billion cubic meters of water by 2025, so relatively fast, compared to the current 1 billion cubic meters per year that we are using today. That would enable us to reuse more than half of the current volume of water coming from the EU wastewater treatment plants for irrigation, for example. And this is a crucial point. Let me talk now from the European Parliament perspective, and European Parliament is continuing to push on this direction, and it adopted during last February plenary the initiative or report on the new circular economy action plan. In this report, we have called on the Commission to propose binding EU targets for 2030 to significantly reduce the EU material and consumption footprint and bring them within the planetary boundaries by 2050. You can imagine how, in this perspective, water and energy saving will represent two crucial elements in this respect, and that's why we need to push and we need to ask the Commission to go on fastly. So at the same time, coming to our today discussion, we called clearly on the Commission to fully integrate the water energy nexus in European policies, because as we have understood today, this nexus is really important for the economic perspective and for this the new paradigm based on resource efficiency and not based on other things. So on this point, let me say that as European Parliament, we will continue to push the Commission to go on. And I think that the European Alliance for Energy Safe, as Monica said at the beginning and said before, continue to discuss and to produce initiatives and to push also from its side towards the Commission and towards the European Parliament in order to really stress this point and to really go ahead fast, because we really need now that this nexus could be more and more go fast and we need to go ahead very with stress. Okay.
Thank you very much, Simona. And indeed, I think that in the whole area of the Green Deal, our issue is to match the ambition with the timing. And the question of urgency is really what also is driving the fact of putting all these agenda together that normally are going their own way. And I think that the big merit of the Green Deal is indeed to say we need to act on different levels at the same time, but to say it is different than to do it. And I think that with this kind of initiative, we try indeed to put together things that are very concrete with the need of the legislation. So I want to thank you very much, and also to have stayed with us. And we will be in touch, as I said, not too much, but we will be in touch. And I hope that you spend a nice rest of the day. And I'm sure that we will meet again. Thank you so much and see you next time. Ciao, ciao, grazie mille.
Bye bye, see you.
Grazie.
Grazie a tutti. Bye.
Ciao.
Ciao, ciao.
Bye bye.